Hello, welcome to this lesson. In this lesson, we are going to look at how we can apply the laws of indices to solve some of these questions. Not necessarily the laws of indices alone, because we're going to apply some other mathematical techniques. So let us see how we can solve these questions right away. Now, the very first question is 4x raised to power minus 3 over 4, and that will be 80 is equal to 88 over 9. Now, to do that, so look, now we are interested in finding the value of x. Okay, now we divide both sides by 4 over 4 by 4. That cancels out, so we have x raised to power minus 3 over 4 is equal to, this is 8 over 9. Now we invert, we have 1 over 4 because this is 4 over 1. So now 4 into 8 is 2. So of course we know that a negative index inverts the base. So that will be 1 over x raised to power 3 over 4. And that will be equal to 2 over 9. So before we continue, if you know that you are not familiar with the laws of indices, I'll drop a link in the description below where I explain to a video where I explain the laws of indices and how they apply in different case scenario. So now let's go on. So in this very case, what we're going to do right here is to invert both sides. Okay, we invert the left and the right hand side. So we just say this is x is equal to x raised to power 3 over 4 over 1 is equal to 9 over 2. So of course this is the same thing as just saying x raised to power 3 over 4. Now, since we are interested in the variable x and the power is 3 over 4, we're going to look for what we are going to multiply the power with, so that at the end of the day it gives us just 1. And we're going to do that to both powers on the left and the right hand side. And that fraction that can multiply 3 over 4 to give us 1 is just the inverse, which is 4 over 3. So we are going to have that this as 3 over 4 times 4 over 3 is equal to, that is 9 over 2 all raised to power 4 over 3, because 4 over 3 multiplies 1 is going to give us 4 over 3. So now everything here when multiplied is going to give us 1. So this is x raised to power 1 is equal to, this is just 9 over 2 all raised to power 4 over 3. That's pretty much what we get from question number 1. Solving question number 1. Now question number 2 is very quickly, this is 1 over 9 into x raised to power 3 times x raised to power 2 is equal to 27. So now what we are going to do is just to clear fraction. And how do we do that? We multiply both the left hand side and the right hand side by 9. So this is going to give us 9 times 1 over 9 into x raised to power 3 times x raised to power 2 is equal to 9 times 27. So, and that will be this 9, cancel this 9. So what is left here is x raised to power 3 times x raised to power 2 is equal to, now this we can express this to the base of 3. 9 is the same thing as 3 raised to power 2. 27 is the same thing as 3 raised to power 3. Of course, you can see that the bases on both the left hand and the right hand side are now the same. So we apply the law of indices to the left hand side and to the right hand side. And that will give us x raised to power 3 plus 2, because the bases are the same. We take 1. The powers are different. Since the bases are separated by a multiplication sign, we have to add the power. Now, and that will be equal to the left, to the right hand side, we do the same thing. 3 raised to power 2 plus 3. So now this will give us x raised to power 5 is equal to 3 raised to power 5. Now again, we can see that the bases are different, but the powers are the same. So we ignore the powers, meaning that they are equal. Then, so we have f of x will be equal to 3. Okay. So then let's look at question number 3. Number 3 says x raised to power 7 is equal to minus 28 is equal to 100. So we just move all the constants to the right hand side, leaving the variable x on the left hand side. Now when minus 28 crosses, the equality sign becomes plus 28. So that will be x raised to power 7 is equal to 100 plus 28. So we add that up, x power 7 is equal to 128. So now again, this 128, we can express it to base 2. 128 is written as 2 raised to power 7, and that will be 2 times 2, 4 times 2, 8 times 2, 16 times 2, 32 times 2, 64, then times 2, 128. So that is written as x raised to power 7. 128 is written as 2 raised to power 7. So again, we can see that the powers are the same. And again, once the powers are the same, it's one of the laws of indices. Since the power on both the left and the right hand sides are equal, and on a single term, now we forget about the power, then we equate the base. So that will be therefore x will be equal to 2. So then question number 4 is 2 x raised to power 4 minus 81 is equal to x raised to power 4. So we just simply group all the terms having x raised to power 4 to the left hand side, and we'll move the constant minus 81 to the right hand side. So that will become 2 x raised to power 4. This is positive. When it crosses, becomes negative. Raised to power 4 is equal to minus 81 crosses the equality sign, it changes to positive. So again, 2x raised to power 4 minus 1x raised to power 4. We have 2 here and we have 1 here. When you take 1 away from 2, you'll be left with 1 of it, which is x raised to power 4 is equal to 81. Again, that that 81 can be re-expressed as 3 raised to power 4. So, and that will be x raised to power 4 is equal to 3 raised to power 4. 3 raised to power 4, because 3 raised to power 4 is 3 times 3, 9 times 3, 27 times 3, which is 81. So again, we can see there that the powers are the same. So once the powers are the same, all you need to do is to equate the base. But you must ensure that on both the left and the right hand side, you have just a single base. Now, that will be, therefore, x will be equal to 3. So that's the answer to question number 4. So let's see, but this very question 5, let's skip it. We'll solve question 6, then we'll come back to question 5. Okay, and I'll tell you why. Now let's see question 6. Question 6 is x raised to power 4 minus 13x raised to power 2 plus 36 is equal to 0. So that is question number 6. So how do we solve this question? So what we'll do is that we apply a little technique from quadratic equation, how to factorize quadratic equation. We're going to apply it here. So what we do is that we'll multiply use the first term to multiply the coefficient of we use the first term to multiply the last term there. Okay, so that will be x. For instance, look at it here. This is x raised to power 4 times 36. This will give us 36x raised to power 4. Now we're going to look for 2 terms. Now when multiplied, 2 terms in x raised to power 2. That is, for instance, this is x raised to power 2, 1x raised to power 2 times 36x raised to power 2. This will also give us 36x raised to power 4. Now, but when we add 1 plus 36, it's not going to give us minus 13. So we'll look for 2 factors of 36. 2 factors of 36x raised to power 4, such that when we multiply them, it's going to give us 36x raised to power 4, and when we add them, we are going to get minus minus 13 x raised to power 2. Now, let me give you an example. 6x raised to power 2 times 6x raised to power 2. This will also give us 36x raised to power 4. Now, if we say minus 6x raised to power 2 times minus 6x raised to power 2, this will also give us plus, because minus times minus is plus. 6 times 6 is 36. X squared times x squared is x raised to power 4. Now, but if we add these two terms here, minus 6 plus minus 6 is going to give us minus 12, which is not the middle term. Now, the factor that will give us that is 4 minus 4x raised to power 4 times minus 9x raised to power minus 4x raised to power 2 times minus 9x raised to power 2. That will give us minus times minus is plus. 4 times 9 is 36x raised to power 4. And you can see that if we add these two terms, minus 4 minus 9, it's going to give us minus 13. So we are going to plug in these two terms. We are going to substitute these two terms, minus 4x squared minus 9x squared, in place of minus 13x squared. So that will give us, this is the two factors that give us that. So we are going to substitute that in the place of minus 13x squared. So that will give us x raised to power 4. First one is minus 4 x raised to power 2. Second one is minus 9 x raised to power 2 plus 36 is equal to 0. I hope you can see that. So now, what we'll do next is to factorize, okay? Take it two terms. Now, what is common here between this and this term is x raised to power 2. Okay, so x raised to power 4 divided by x raised to power 2, we have x raised to power 2 minus, now 4x squared divided by x squared will give us, we'll be left with 4. This minus, what is common between this term and this term? The constant first, 9 is common. So 9 is common. So 9 into 9x squared. 9x squared divided by 9 is going to give us x squared. Now, plus 36 divided by minus 9 plus 36 divided by minus 9 is going to give us plus divided by minus is minus, 36 divided by 9 is 4. So that will give us minus 4 is equal to 0. So we take the common terms, and we'll have x squared minus 4 in brackets. We put the other terms in bracket, that is x squared minus 9 is equal to 0. So when two things multiplies to 0, for example, if a times b is equal to 0, is either a is equal to 0 or b is equal to 0. So since these factors, this times this gives us 0, so it's either the first term here, x squared minus 4 is equal to 0, or x squared minus 9 is equal to 0. Now we'll take this first case. Here we have x squared minus 4 is equal to 0. So we move this way. So we have x squared is equal to 4. So we express this to the power of to base 2. So that will be x squared is equal to 2 raised to power 2. Because 2 raised to power 2 is 4. So again, we can see down that the powers are the same. So we equate the base. So therefore, the first value of x is x raised to power x is equal to 2. That's the first case. Now in the second case, we have x squared minus 9 is equal to 0. So we'll move 9 this way. We have x squared is equal to, when minus 9 crosses equality sign, becomes positive. So that will be 9. So this is x raised to power 2 is equal to 9 is same as 3 raised to power 2. So now since the powers are the same, all we need to do is to equate the base. So therefore we have that x is equal to 3. Okay, so the values of x are, the first case is x equal to 2 and x is equal to 3. Okay, so now let's look at the fifth question. Now the fifth question says that 5x raised to power 4 is equal to 81 minus 4x raised to power 2. So what we need to do is to bring all the terms to the left hand side and be left with nothing on the right hand side. So that would be 5x raised to power 4 plus 4x raised to power 2 minus 81 is equal to 0. Again, when this is positive 81, when it crosses becomes negative. This is minus 4x squared. When it crosses to the equality sign to this side, it becomes positive. So, and again, nothing will be left on the right hand side. So that's why I put 0 there. So now again, if you look at this, we are going to try to try to factorize this expression. How do we do that? We multiply this first term by the last term. So if you do that, you have 5x x raised to power 4 times minus 81, and that will give us minus 405x raised to power 4. Now, if you look at this, what two terms are we going to multiply so that when we add them, what two terms in x squared? Now we can write this as, say, 5x raised to power 2 times minus 81x raised to power 2. That will also give us minus 405x raised to power 4. Now the question is, what two terms are we going to multiply to get minus 405x raised to power 4? And we'll add them. We're going to get the middle term, which is plus 4x squared. Now let us try. Now this is the first factor. Now let's look at another factor. Another possible factor can be